Euclid's Elements, Book 4, Proposition 1. Into a given circle to fit a straight line equal to a given straight line, which is not greater than the diameter. Got our given straight line, which we'll call A. And we've got our circle. And so what we want to do is fit into the circle a straight line which is equal to A. And what Euclid means by fit in the final definition of Book 4, it means that the straight line will have either of its extremities on the circumference of the circle. So first step, we'll draw a line BC, which is a diameter of the circle. So BC equals the diameter, and we'll call this circle B, diameter of circle BGC. And if BC is equal to A, then we will have done what we were supposed to do, because BC has been fitted into the circle, namely its extremities are on the circumference of the circle at B and C. But if BC is not equal to A, if it's greater than A, then we're going to cut off from BC a line that is equal to A. We can do that by Proposition 3 of Book 1. And we'll cut off line BC equal to our given straight line. And then using one of our postulates from book 1, postulate 3, we can create a circle of any size. So with EC as our distance and C as our center, we're going to create a circle. And we'll call it circle postulate 3 of Book 1. We'll create circle EDC. And where they intersected, we label that point D, and then we're going to connect D to C. Now we know that EC and DC are radii, so that means they're equal. So EC equals DC because they are radii of the circle EDC. But EC was made equal to line A, and therefore DC by common notion number 1 must be equal to line A. So common notion number 1, DC equals line A. But DC is a line that has been fitted into our original circle BGC because its extremities are at D and C, which are both on their circumference respectively. Therefore, QEF.